I would like to talk and take the chance now to discuss with you for the future of Automotive Scapy, also a little bit about the past. Automotive Scapy, therefore, because this is where we are basically working in. This is our field of expertise and where we can do contributions that make sense to the tool. So therefore, please join me in this discussion. It's not just a talk, it's an interaction with you, and let's see how this comes out. But before we discuss about the future problems, I would like to tell you a little bit about the past, the present of things we're doing in the automotive security layer, and then we can think about how we can solve future problems together, ideally. So in the past, there was the enablement of Scapy for automotive networks. We added a few basic protocols and protocol scanners for automotive systems. Today we are focusing a lot on Ethernet-based, automotive Ethernet-based protocols. Also SecOC is getting more and more popular, and it also has a lot of challenges for us, which I would like to discuss later, because we need to think about the future. And with the community here, I want to get your opinions on how we can tackle the problems for the future. I mean, missing protocols is a simple thing, right? We just need to add them. But customization possibilities are a big problem, especially in the automotive industry. Also, how we can handle proprietary standards and how we can make new tools or utilities inside Scapy, similar like the CRC function Philippe just showed us. So this is what I would like to discuss with you. First, how did it start? Like, as I said, we started in 2018 with the automotive Scapy editions. At this time, I was about to write to start with my PhD thesis and to focus on automotive network penetration testing. And there were many tools out there for doing certain things with CAN. Car-in, view is probably well known by a lot of people. Also, Metasploit started to do a sidestep in the automotive security area with some weird connector, but it didn't work out at the end, at least not for me. Then there were some other projects. One was, I think, founded by Bosch, even like Busmaster, or by ETAS. And basically of these tools, I took a little bit the Git commit history to see if this tool is actually alive, right? And outstanding here, Scapy has the longest history. Scapy is the oldest of all of these tools. Metasploit is close. Metasploit has obviously some more commits, but the focus is different. Like Metasploit is an exploit tool for the web world, and Scapy is more the networks. So therefore we decided to take Scapy and to add the automotive stuff. This was Scapy at the time when we started with it. Remark here, this stack is completely incomplete. It's just shown like the most relevant layers or that I see necessary for the automotive network stacks. But there are like many more protocols which were implemented in Scapy at this time. But unfortunately, there was just CAN as a packet definition, so you could only read and write PCAP files at this time with Scapy. And this is where we started. Besides that, Scapy had a lot of great functionality, like reading and writing PCAP files out of the box, sending and receiving packets with SR, which was one of the main functionality, and also answering matching so that you can associate a request with a response and you get them together and you can make more sense out of it. So our first step was to add a lot of automotive protocols, especially on the lower network layer. We added CAN sockets. The Linux socket CAN system made it really easy for us to have an extremely performant way to send CAN messages. But the Scapy maintainers pushed me also to implement something for Windows and for OS X. So we needed to write a wrapper around Python CAN to integrate Python CAN into Scapy. And unfortunately, Python CAN didn't have the concept of sockets here. So you only so we have a concept of a bus in Python can, and it's a singleton, and if you assign it, no other process can basically use this bus anymore. And this is a little bit sad, and so we need to reinvent the socket functionality in Scapy to have both the CAN sockets of both worlds being replaceable immediately, that you can use either the other one or the other one. That it doesn't matter for your application if you're running the script on a Windows machine or on a Linux machine. Only the lower layers are different then. Okay, we also added support for CAN dump. This is, let's say, the pendant to TCP dump, just in the CAN world. And then a lot of signals that we needed to define DBC information in Scapy so that we can create a more human-readable message parsing that is done in the automotive industry with so-called DBC files, and therefore we created a lot of signal packets or signal fields. And additionally, CCP as a protocol, ISOTP and ISOTP sockets. But here again, ISOTP sockets also gave us some headache. I think me and Enrico were rewriting the ISOTP sockets like 3, 4, 5 times. There was a lot of refactoring, especially the ISOTP soft sockets, because in order to send ISOTP, you need something running in the background which is listening for packets and replying like an answering machine, basically. And at this time, it was a little bit of a performance issue, because we also needed to use Python can underneath, because we wanted to have ISOTP sockets available in Windows. And again, on Linux, it's easy. It's the ideal world. You just tell the socket, hey, I want to talk ISOTP here, and you get your ISOTP messages. So Linux was always easy, and Windows was always hard. Additionally to ISOTP, we added a lot of tools to defragment and fragment CAN, and then some higher level protocols, OBD, UDS, GMLAN as an application layer protocols, also eNet and eNet sockets, because at that time I thought the protocol is called eNet, but I come to this point later, and first implementations of some IP. So these were our first steps. And then I continued with my research and added a lot of scanners and parsers to the Scapy project for the automotive layers. Now, let's start with this thing. eNet changed to HSFZ. So this is a BMW proprietary protocol, never documented anywhere publicly. And I thought it's called eNet, but I was actually wrong. So it's called HSFZ, which is High-Speed Fahrzeugzugang for the German ones here. So I had to change the name to be more accurate. Also, we had to add CanFD because CanFD was coming, and we had ISOTP messages over CanFD, which is a different format now, and diagnostic over IP, which is also more and more coming in the recent ECUs to use IP connections for the diagnostic interfaces. Additionally to diagnostic over IP, we added diagnostic over IP sockets, which is a wrapper that gives you directly UDS packets, because often you don't care about that much about the transport. You directly want to speak UDS to an ECU. And then the same with XCP as a protocol and XCP scanners. Also at this time we did a lot we worked a lot with Opel cars, and they were based on GM architectures, and we did some exploitation of them. So we added GMLAN utils there that allow you to have some handy functions to exploit GM bootloaders, basically, like helper functions that allow you to directly read huge portions of memory and that kind of things. Also, we implemented an ISOTP scanner. So there was Karimbu at this time, which was doing a similar thing, but they were completely focusing on the application layer. And in Scapy, we implemented an ISOTP scanner, which was a little bit different and therefore also unique, because we were only touching the transport layer and never leaving the application layer, which is a nice thing if you think about sending malformed ISOTP packets to a random ECU or to an entire car, because you will never trigger actually a complete UDS message. And sometimes you don't want to trigger anything in UDS because it could change the ECU, it could brake the car, it could start an action in the car, some physical action, which can have some danger. And therefore we implemented the ICTP scan in a way that we send malformed packets of the transport layer, which is unique in the scanning as far as I remember. But then the biggest thing was for me the UDS scanners. So we built a lot of full-fledged scanners for enumerating all the different UDS services, and basically in a stateful way, because whenever you send a UDS packet, you might change the state of your ECU you're talking with, and so you need a tool to track the states of your ECU by guessing. By guessing what the state is now, because you usually don't have a documentation from the OEM, and you just know that these things change the behavior of the ECU, therefore I need to assign a new state. So the scanners need to be aware of the states, and this is why I implemented those state-aware scanners, which try to guess the state by the answer of the ECU and build an internal system state graph of the ECU to traverse in this graph and to do certain actions in certain states. The same GMLAN and OBD, but OBD is stateless, so OBD was simple. And also I added a few additions. Volkswagen, BMW were for ECU specific things. I also had a huge addition with Mercedes specific definitions, but then the guys wrote me, can you please take this down? So they were removed. But I think they're still in the Git history, because Git never forgets, right? And on the side, some ECU utilities, which I used sometimes internally in the scanners, like stateful parsing of log files, so that you can take a UDS log, for example, and you parse this log, and the stateful parser tells you also the assumed state of the current system or the ECU you're talking with, and also simulation. So a lot of things were coming at the end of my thesis, kind of in the project. And then the latest things we did, diagnostic over IP is evolving. Now we have diagnostic over IP over TLS, so we also need to add a way to talk TLS with diagnostic over IP. We reworked some IP to make it more usable, because there were some quirks in the Scapy packets which were not so nice, which made it hard to craft the packets on the fly. Also there were AutoSAR PDUs coming. Additionally to this, also AutoSAR SecOC PDUs and SecOC over CanFD. And recently we started working a lot with ECU simulations over automatons, so that we can simulate ECUs, that we can simulate the states of ECUs in order to use those for especially unit testing and testing of our security suits that we work with. And yeah, again, I also started to talk about, I wanted to do an educational part in this presentation, since I'm finished with the history now, and I wanted to give you something from my point of view. So I thought also, yeah, automatons is a great feature, but it's actually used pretty little. This is at least my impression, because also for me it took me quite a while to understand them. So therefore, yeah, I wanted also to point to automatons, which is a great tool to craft your to go after network automaton, or basically a stateful answering machine to handle certain stateful protocols or certain initial handshakes that you need to use when you work with your ECU. And also again, an automaton can work either as a client or as a server. So you can do both sides. You can make a very stateful request automaton that reserves the state, or you can make a server that serves you something in a stateful way. And we can use this, and we have great use of those in automotive security penetration testing. For example, so internally we use it a lot for ECU simulation, so we can really ramp up an ECU quite easily and simulate the UDS protocol with those automatons. And in this way we have a virtual ECU, or the commercial term would be software in the loop system or whatever. So in this way we simulate the ECUs, and we use the automatons for this. Also another thing is the SumIP protocol, because SumIP needs a handshake, especially for certain variants of the protocol. And this is especially annoying when you want to work with an ECU to talk some IP, because you need some initial code in order to make the ECU work. So the same problem as you also had at your time. And therefore, we can use now the automatons to make to have an easy and flexible tool to do, for example, some IP handshakes in order to make the ECU talk to us and in order to enable the ECU to be able to talk with us. Otherwise, the some IP ECUs keep silent often. SecOC is another use case that we encounter more and more, because we also SecOC, like it's a new security protocol. I will explain it in 1 or 2 slides. But it also needs some way of rest bus simulation. You need to exchange certain message periodically in order to properly work with SecOC and to make your ECU believe it's in a proper network and to properly send out SecOC packets that you want to inspect. And the last thing which came to my mind is over-the-air update servers. So now the ECUs all get over-the-air update systems. Sometimes they have an implementation based on HTTP with some requests of certain things. And if you want to mess around with that stuff, then you also need to have an answering machine where you quickly can set up an update server that can ship malformed updates, for example, to your ECU. And therefore, the statefulness of these automatons is an awesome feature that allows us to have pen tests here done really quickly. So now some code, because this is the educational part. ECU simulation, the slide is a little bit off. I wanted to quickly show how we use the automatons to simulate ECUs. So first of all, I want to have an ECU being able to turn this ECU on and off. Therefore, I have 2 states here, the ECU off and the ECU on state. And from externally, I have a simulated power supply, which is basically a file descriptor that I can toggle on and off. So whenever the file descriptor is readable, the I/O events of the automaton directly read the latest byte, and then I can decide to change the state, either to turn my virtual ECU on and off. Also, additionally to this, I have the so-called actions of the automatons, which I can use to simulate the power consumption, because maybe I also want to simulate a power sensor, a power consumption of the ECU, and I can do this in the action, which is added to the I/O event. So whenever the I/O event happens or the change of the state happens, then the action is triggered. And yeah, with the latest versions of Python, we also have now this match constructors, which are a great thing for us to simulate ECU UDS responses. So with, let's say, a very little code, we can simulate the entire spectrum of UDS responses of a virtual ECU, because ECUs are very precise in how they answer. They have the UDS protocol implemented, and they are very descriptive about what was going wrong in their UDS negative responses. And with Scapy, we can just take a few lines here and model our negative response for all of the cases where things go wrong. As for example, I have a tester present function here. So if I see a tester present with the length of 2 and the subfunction of 0 in this match constructor, I answer with the proper tester present response, positive response packet, because this is what I expected. On the other hand, there is another subfunction, or it's specifically a bit in the UDS protocol, which tells us suppress positive responses. So if this bit, if the most significant bit of the subfunction is set, some services don't respond in a positive case, and this is what I do here. This is why I return none. But then it becomes interesting. Whenever something is going wrong now, I have a defined negative response for that effect. So for example, the subfunction is not in my list here. So I was falling through 0 and 80, which are the good cases, and all the other subfunctions are now mapped by this match operator. And in this case, I have the correct length, but the subfunction is just wrong, and I can directly respond with subfunction not correctly. Or if the length is not 2, in this case here, I can respond with incorrect message length or invalid format. And if even the service is wrong, I can directly respond with service not supported. And in this way, I have very little code to define all the possible negative responses that I want to simulate in my ECU simulation. Okay, then a hot topic. I called it hot topic, SecOC. We also have a talk today about SecOC, and I'm looking forward to it. For those who are not that familiar with SecOC, we have the standard, and the standard is an ideal world. Everything is nice and shiny here in the standard, and we have a lot of definitions for things. So it's defined how a PDU is basically authenticated with a counter and with a message authentication code. And then those things are truncated and added to the packet. The packet is sent to the receiver here, and then the counter and the authentication code, the truncated ones, are unpacked, and message verification is done by generating again a same MAC and comparing the truncated values to the generated ones. So straightforward, and yeah, what could possibly go wrong here? First of all, we have the freshness values and the authenticator. Also, the standard defines everything, how we need to truncate them, how many bits of the freshness value we have in the packet, and how many bits of the authenticator we have in the packet, and how the secured PDU looks like. And then the standard goes even further. It defines us the freshness value, how the freshness value is computed. Unfortunately, this is a little bit hard to read, but you have several different counters, trip counter, reset counter, message counter, that goes into this big freshness value, and this is how AutoSAR supposes us to create this freshness value. Also a reset flag here. And it goes even further. The standard also defines how the synchronization message of the freshness value looks between the ECUs. This is the one here on the bottom. So this is also the counter values, the trip counter and the reset counter. They are getting authenticated as well, and then we can exchange them between different ECUs that talk SecOC. So if you think about the standard, everything is nice and shiny and ideal and well defined. But then if you come to an actual ECU project, shit goes on, because like the problems occur in all layers. First of all, the MAC generation. It's unclear how the MAC is actually generated. So is the CAN ID part of the ECU if you are on CAN? Is the PDU ID part of the MAC if you are on AutoSAR PDU fields? Do you add the length field of the CAN message to the authentication? Does the OEM use padding, for example? Some OEMs do apparently, and they change the length of the PDU randomly. But all of those things you need to know. Then the freshness value. It's just because, I mean, if you would just follow the standard, that would be too easy, right? So OEMs do their own standards, and they start to roll their own implementation of the freshness value. So instead of using this well-defined standard freshness value implementation, they, for example, exchange some tick counts over the network and use this as a freshness value. Then they also need to think about what happens if the truncated freshness value is rolling over. How can you handle this? And you need to think about this because you want to pen test this thing. And also sometimes they use custom authenticators. Then they have custom ways to reset the freshness value. So maybe they don't start from 0 on every boot up. They start from some persistent value, and you need to think about that one as well. And then what about the keys? You need some key management. The ECUs have keys for the creation of the authentication, but are those associated with a PDU ID, or is there a data ID which is just known to the OEM? And it doesn't really match the CAN identifier or the PDU identifier. Then what about the synchronization key of the freshness value? where is it, how does it look like. Maybe they have custom derivation functions for the keys so that they have a master key, and then out of this master key they mix in the CAN identifier, apply some hash functions, and then you get a custom derived key for your CAN messages. That might be a thing. And you also have to think about key storage and how the key update is handled. So the reality becomes pretty complex pretty fast. And this is what is troubling us. And I just brought up all of this mess here because I wanted to get you an idea what's coming to our brains when we think about how can we bring this into a Scapy protocol. Because what we want ideally is like an implementation for SecOC that we can just run and use. But yeah, unfortunately, as I initially explained earlier, it's not so easy. We need to do some customization, and the best thing what we could do for now is we implemented like a basic protocol that has functions you need to overload in order to make it that much versatile that you can customize it to your OEM's specific implementation. And this is again another big problem because the actual implementation is under NDA by the OEM, and so you don't get it, and it's also hard to get it in an open source tool, right? But if some people from an OEM here, maybe we can discuss this, how secret those procedures are actually, and if it's feasible to have something in an open source tool that allows us to just work with the packets and do our penetration testing, for example. Then, we need a generic basis implementation in Scapy, which is not associated with an OEM because we often have NDAs, and so we do keep the things generic. This means they don't work out of the box. You always need some manual customization in order to make the implementation usable for you, which is annoying, and I would rather prefer to have like something which is working out of the box. And yeah, the question is, for example, are code generators a solution? But then think about how complex can a code generator be if you think all the protocol variations of the OEMs, and even they mess them up. So sounds like a nightmare. What we did so far was we implemented a basic SecOC, for example, over CanFD packet, and you need to have 3 functions here that need to be filled, and in these 3 functions the packet has to give back its payload, its key, and its freshness value. These are the 3 components we need to do the computation, the 3 basis components. But however, it's not clear in the actual ECU where does the payload, for example, come, or what does the payload contain. As I said earlier, does it contain padding or not? And here I put a bug here, so this shouldn't be a race, it's a return. It's a small typo. But yeah, I wanted to introduce you like some of the problems we are facing with when we want to bring something new to Scapy, especially in the automotive protocol world, and these are the questions we have in mind. So yeah, thank you. Not actually, because now the active part comes. I'm gonna test this now. I have this Mentimeter thing here. So let's see if that works. Okay, looks good. I want to have your feedback, and I want to make this a little bit interactive. How can we make Scapy better in the future? And I have a few topics about automotive specific things. I just introduced like one big problem, the customization, but there are, in my opinion, 4 different problem areas we are currently facing when we think about developing the tool for future use. By the way, do you need the QR code again? Yeah. So please take part of this survey. I'm looking forward to the outcome. I have no idea what happens, but so curious. All right. Because also now we have time for discussion. So whenever you want to say something, please don't be shy. We have 2 more microphones here. We can start discussing things, and I really want to go in exchange here. So this shouldn't be like just a demonstration. whenever you have a good idea or something to mention, please let me know. All right, so more and more people are coming. Yeah, there's like a Wi-Fi here. It's called Techbase Guest. It's free. You just need to sign up because usually network is bad here. Okay, maybe let's give it a few more minutes, or like a minute or two. Yeah. A second. Can I check it, please?
Yes.
Yeah.
Thank you, Nils. I just want to understand your standing once more. So actually the point with the SecOC, and especially when you are in a penetration testing, you most of the time have already access to the OEM or the tier one and their documentation. But the platform is that, or you would like to be the platform provider, so you cannot just implement them, just put them into the Scapy and then distribute it to everyone. This is your standing, and this is what you want to find a solution, right?
Exactly. This is exactly one point, for example, that we have these custom modifications because they don't just take the AUTOSAR standard as it is written or the ISO standard for their protocols. They modify it and they do it in a custom way. And so we cannot just take it and put it to an open source project to have a tool which works out of the box. Instead, we always need to dig deeper in the standard and to make custom modifications in order to get it up. Yeah. Thanks.
Understood. And these three additional, I think you call them payload. What do you call them? The three functions with the payload, the key, and the fetch. Exactly. You kind of try to provide an option to customize and make it work everywhere in the different project and OEM environments.
Exactly. But it's a way to work with, but I mean, I would like to have a better way because it requires manual work, and I cannot just say, okay, today I'm testing the SecOC implementation of Mercedes, and I have the SecOC implementation of Mercedes in Scapy and can use it. Or I say, today I'm testing the SecOC variant of BMW or Volkswagen or whatever, and I cannot just use it. Yeah.
Okay, that's great. Thank you very much for the confirmation once more. It is now more clear for me to look at it from the platform perspective. Thank you.
Absolutely. Yeah, exactly. We are thinking about how can we make things more accessible and more useful for others, especially when we provide open source tools. All right. So then we have a lot of people now here. Then automotive related problem areas. Missing protocols, as I said, is easy, so we just need to add them in Scapy. This just requires work. Another problem we have is proprietary file formats. So in the automotive industry, again, we have a few proprietary file formats that we need to work with in a penetration test. And my question would be, what makes sense to integrate and what not? Also proprietary protocol modifications. This was, for example, the SecOC case, but I have more examples which I discuss in a second. And then security is coming. We have security features everywhere, and it's becoming difficult actually to do a pen test because of the security functions you need to first solve together with the OEM. So missing protocols, from my opinion, I came up, okay, what's missing in Scapy at the moment that we definitely need somewhere in the automotive world? For example, LIN, FlexRay. Question is, does anyone work with CanXL so far? No. Okay, cool. Time-sensitive networking is a protocol which we see in Ethernet. We have audio-video bridge in automotive Ethernet ECUs. Then there's this protocol J2534 pass-through, which is a nice protocol of its idea. That's basically the definition of a DLL or of a library. So whenever you have a automotive diagnostic interface that supports J2534, you can take a standard tool because it means you have a DLL that has certain defined functions that you can use to send messages directly to the car or not. J1939 is a heavy-duty vehicle protocol, similar to CAN but with some small additions. We also have, for example, AUTOSAR network management as a CAN-based protocol. We also have AUTOSAR DLT, trace and linking. And then there's also V2G. I mean, we have a talk today about V2G. Scapy has a basic implementation, but I think it could be improved. And also missing protocol utilities. For example, at the moment we don't have an ISOTP over KNFD scanner. The XCP scanner is very limited, and the V2G utilities are also not present yet. So therefore, my first question would be, in your opinion, what protocols or utils are missing? What are protocols and utilities that I maybe didn't mention here? Does something come to your mind? So please give me your feedback. Do you work with some really exotic protocols? Did I just forget something here? And yeah, FlexRay, I have to admit, we will not implement FlexRay. 10 gigabit automotive Ethernet, is this a thing? Fuzzing. Oh, yeah, cool. Oh, nice. OCPP is new to me. Maybe someone want to. What is it? Like, can you give a short explanation?
Yeah, that was mine. I'm from the EVSE universe, and OCPP is Open Shaft Point Protocol.
Okay.
It's usually used for backend communication, but we had a use case where it would have been nice to have a UCPP utility in Scapy.
Okay, thanks. Yeah, 0x29 is actually basically implemented, but like in a basic way. So it needs probably more some more information. But I come to this also later. Yeah. But thanks. Bluetooth is also partly implemented. I'm not sure how the status of the Bluetooth layer is, since I work very little with Bluetooth. Oh yeah, MOST. I forgot MOST because this is also, yeah, well, I don't know. I hope MOST goes away. Same as FlexRay. I hope they get all replaced by automotive Ethernet. But yeah, because just getting media interfaces, getting an interface for a Linux PC for those kind of protocols is already pretty hard. Is there actually, does anyone know a FlexRay Linux interface that you can use with Linux and do FlexRay? Okay, yeah, it's a challenge. Okay. Ultra wideband. Oh, interesting. Yeah, ultra wideband. Yeah, if you have proper software-defined radios, then ultra wideband might be a nice thing. Presentation mode as PPP. What does this mean? I'm just curious. Okay. Anyway, doesn't matter. So thanks for the responses. Now the next slide is very similar, but now I would like to, from also the other list, and in your daily use, what are the most important protocols for you? Just to give me some idea, what is the major protocols you work with? Yeah, what is the main protocols you need to touch every day? UDS, perfect. FD. Oh, CAN-TP is ISOTP, I guess, right? Yeah. Oh yeah, nice that UDS is coming up that big. Okay, I guess NM is AUTOSAR network management, probably. Okay, then thank you very much for these insights. Oh, 52 responses, wow. Okay. Then I would go to the next slide because I would like to introduce the new problem field here. It's proprietary file formats. So on one hand side, OEMs like to define their protocol descriptions in proprietary file formats, as for example ARXML, DBC, or ODX. So those are like description files that certain OEM tools can load, and then they get the definitions of the signals, of the CAN messages, and so on. And I mean, we build ways to have Scapy flexible in a way so that we can load, or that we at least can customize and import custom definitions for certain protocols, and they do it all over the place. The next thing which we see, which is coming more and more, especially on the Ethernet-based ECUs, that we have network descriptions also in this ARXML files containing, for example, VLAN identifiers, containing network architectures of the vehicle, all in these proprietary files. And then we also have flash files for software updates, for example ODX again, where ODX holds the entire binary blob, or an older standard I know is CFF or CISA flash files. And again, your question, which other files do you know and do you need to work with on a daily basis? What kind of file formats are the ones which are in your daily life? FIF, nice. Yeah, okay. FIS is a good one. FIS is the update file of the Volkswagen group. So Volkswagen encodes their software updates in FIF, which is actually a zip container, but this one is encrypted with a proprietary key. I'm not sure if Volkswagen is happy if we put key material to decrypt their FIF files into Scapy. But yeah, you can find it. Brian Ledbetter had a nice GitHub repo where you could find the FIF keys. PDX, you see, CDD is probably the CISA debug definitions, I guess. I'm not. Huh? Candela Studio. Ah, okay, yeah, Candela Studio. Yeah, yeah. This is also a vector-specific format from the guys over there, where they define the diagnostic specification. And maybe do they also define the CAN messages there?
No, just
the diagnostic. Yeah. Okay. What is mod? Mod file. Okay. SREC, I think this is, I guess, also a software update file, probably like an Intel hex file, but in an encrypted way. Is this correct?
I think Motorola S record is.
Ah, okay, Motorola. So it's like Intel hex, but for Motorola. Ah, okay, thanks. Yeah. DBC for CAN messages. Fine. Okay. Thanks. And now the next question. Which files should be maybe supported by Scapy if it would make sense? So I can think of, for example, you have there's like one project which is called CAN Matrix. I don't know if you know it. It's on GitHub, and it has, for example, a conversion for Scapy actually. So you can load a DBC file or ARXML file, and it can somewhat generate you packet definitions that you can load into Scapy in order to parse DBC files. But again, it's a lot of work. Same ARXML is like huge. Recently we had an ECU and I looked in the ARXML file and it was 500,000 lines of code, like 500,000 lines of XML. So, I mean, it's not fun. It's definitely not fun. Okay, yeah, ARXML is, so I guess we need to think about an ARXML support for Scapy so that we can maybe load some basic signal definitions or something like this directly. This sounds interesting. Thanks for your feedback. Then the next problem, proprietary protocol modifications. As I introduced with the SecOC problem, we also have the same for CAN signals, for PDU signals. Also on AutoSAR PDU, there's this AutoSAR PDU protocol, which it's like CAN over the network, over in a UDP packet. But again, in the protocol themselves. The OEMs define the information in so-called signal fields, and it's really uncertain what the information means there. So if you don't have an ARXML file or a DBC file, you can often not make any sense out of these protocols. Some IP is similar. They also communicate information like this PDUs over some IP. Then UDS subfunctions is one thing that tackles us often, that the OEMs have completely custom and proprietary subfunction implementations of UDS. And you need to know the ECU. Sometimes you're lucky and at least the bootloader follows certain standards in the subfunctions of the UDS services. But then again, if it comes to UDS flashing, again, it's really custom. They all have their own slightly different way of flashing the ECUs. For example, request download with address ranges is always unique. So sometimes you have to give a memory address and a length. Sometimes you give a logic block. Sometimes you need to add something or call a weird function before, and then you can flash things. So it might be a thing to have a basic UDS flashing functionality in Scapy, but then again, we have a lot of need to make this protocol again generic so that you can customize it enough that it is useful. And auto updates are coming also again with completely proprietary file formats. We saw all kind of things, HTML, JSON, things like that. So what other proprietary file formats and modifications to protocols do you know, if you know any? Just out of curiosity, what other protocols have you ever seen a custom UDP implementation, for example, or things like that? Is something like this happen to you? Okay. Good. Well, if there is nothing, oh, there's one. Custom XTP user commands. Nice. Thanks again. Thanks for this one. Also, if I remember correctly, XCP also have this data acquisition points, DAQs, which are completely custom, and you can basically specify which kind of data fields you want to read from the ECU, or you want to get notified over XCP. Yeah, that's a good one. All right. There's nothing more. I go forward. Oh, there was one. Sorry. MCMP. That's interesting. I never heard about this protocol. Can someone UDS manufacturer and sessions? Yeah, again, yeah, the standard UDS problem. What is MCMP?
MCMP is to flash slave controller from master controller.
Okay. So like Lin, for example, is it Lin in this way, or?
It's based on CAN.
It's based on CAN. Okay, thanks. SFD, yeah, sichere Fahrzeugdiagnose, Volkswagen protocol. Yep, this is annoying. I come to this point in the next slide because VKMS, what was it again? Vehicle Key Management System. Also, yeah, nice proprietary world where we are in. Okay, thanks for this feedback. Then. Security, because this is now coming, like all ECUs get secure, and we see VKMS and we see SFD all over the place. Basically, the OEMs now require authentication to the back-end systems in order to speak diagnostic protocols with an ECU. So this is the OEM authentication. Also, we saw UDS 0x29 previously. This is the UDS authentication function here, which is exactly this functionality. So without authenticating on the ECU doesn't speak UDS with you, which is pretty annoying because you cannot even start playing around with the ECU when you get it in your hands. Also, another thing we saw, diagnostic over IP certificates. Since we now have TLS on diagnostic over IP, it might be a case that we need specific client certificates in order to authenticate to the ECU in order to speak or to establish diagnostic over IP connections. And also SecOC, again, SecOC keys are coming, and without SecOC keys I cannot craft any message anymore on the networks. That make any sense. So without SecOC keys I can't do things. And for us, we think about the perspective of a penetration tester or security tester, it creates a lot of problems, because in order to start like a penetration test, we need to sign NDAs with the OEMs. Okay, that's we always have to sign NDAs, but then we need to get tools, access to their tools, to their proprietary backend tools in order to have authentication functionality to the ECUs under test. Also, we need to get the certificates, and we need to get SecOC keys in order to do our testing, which makes it really hard and which wastes a lot of time, because you need weeks until you get the tools, and you need to install the tools, get them running. You need to take some Windows machine, maybe you need a proprietary vector tool in order to work with those software, and then you are good to go. And this is really sad. So ideally, I would like to have a situation where we could, for example, have a adapter to the backend services of an OEM as part of Scapy. And my hope is that this is not crucial for an OEM, because it's actually just a wrapper that talks with the backend, gets the key material from the backend, and we would be immediately good to go, for example, to do UDS authentication, or do the diagnostic over IP authentication with the proper certificates. But in this way, we would need adapters to the backends, and again, you only get this information through NDAs. So my question would also be, if someone is here from an OEM, what his point of view is about, or her point of view about if this is, in their opinion, a critical piece of software for an open source project to have an adapter to a proprietary backend in order to craft the proper UDS messages to do the authentication for an UDS job, so that you don't need to waste a couple of days creating the adapter yourself, or that you need to buy some random tools that do this. So maybe you have an opinion here. But also I wanted to ask you, what other security mechanisms did you need for ECU testing, do you know? I mean, we already had VKMS, we had SFD, which is all the same thing. Did I forget something? What other measures do you take to protect your ECUs? JTAG keys, yeah, nice. I completely forgot about JTAG. SFR, okay, that's new to me. Maybe, what is SFR?
Secure feature activation.
Secure feature activation. Oh, that's also a nice one. Debug access, diagnostic protocols. EOL, I guess it's end of line testing, end of life activation, something like this. Or is it a completely different thing? Okay. IDP, what's IDP?
Intrusion detection protection.
Intrusion detection protection. Oh wow, we get intrusion detection actually in the ECUs. Service 84 is new to me. What is Service 84?
Secure data transfer.
Secure data. Okay, thanks. Okay, VLAN. Yeah, VLAN specific VLAN tags. That's a good one. Okay. So maybe if someone is here and would like to say something about this, about what I just said about his opinion about having access to backend systems and an open source tool, is there someone here who would like to comment such an idea? Yeah, sure. There's a microphone. Yeah, look.
Why do you want that?
To make life faster, basically, or to...
For the people testing?
Yes.
Is that inside the OEM?
Well, for the people testing in general. Yeah.
So one thing that the people testing usually have is access to the ECU on the other side. Mm-hmm. So we can make that software less secure, so that it accepts any certificate. So we generate a certificate for you now
Yeah.
for your person, and we will code that into that.
Yeah, exactly. I know that. Yeah, this is one way to do it on the OEM side. Yeah.
And then you don't need any interface to the backend because you have hard-coded
Absolutely.
data. Because if you need really access to the backend, that is per user, so it will be for your system only. You cannot publish it in any repository.
Okay. Yeah. Thank you for your comment.
Yeah, I have a small question. We thought in our company to use Scapy as a basic for like the platform to start with and build a product upon it. But because of the license, it's not really possible to put IP features inside our product.
Exactly.
So I wonder if the Scapy license was a bit less.
That's GPL v2.
Yeah, like for example, like LGPL or something like that. Maybe it could allow many other resourceful companies to use Scapy as your basic, and then to add additional capabilities to Scapy just as donation, because they're using your code and they would like to share this.
Interesting point, but yeah, I think we don't need to. I mean, it's not feasible to change any license, and I think it's not a point of discussion here for the license.
Any other points? Yeah. Thank you. So the license issue, it's not the first time it arises. At the beginning, so 20 years ago, when I chose the GPL v2, first of all, none of the existing set of licenses existed. I'm quite happy with the GPL v2, but it means that because things like CLA, so contributor license agreement and things like this did not exist. It was not a standard practice at the time. And because we have like 400 contributors, it's very difficult to change the license. But it's not something I do not consider, so you're not the first one to ask me for a license change. It's something I've already looked into. I'm still thinking about ways to be able to do it. I would like to keep. I mean, I think I will have a Scapy GPL forever, but maybe a code base with another license existing with the agreement of all the contributors. This is something that may happen. But I make no promise here because it's very difficult for many different reasons. But don't lose any hope. There is some, I think.
Thank you. Do you want to answer this one? Or?
Maybe. Yeah, so actually we thought about maybe creating our own open source, like to start with the protocols we actually use, and maybe publish it as an, I don't know, MIT or lesser license in opinion that maybe someone else can donate and contribute as well. So maybe it could be some joint forces between you and actually companies that actually use this as their platform. And in that case, you could have additional contributors with resources from the beginning. So in case the license is more permissive, it could help a lot to initiate those kind of repositories.
Yeah, that's something I consider. Okay.
Cool.
Thank you. So, any other points that we can discuss? Any other ideas, comments in general? Okay. Yeah, sure. Thanks.
So you were asking about the SecOC protocol, and then you were asking about the ARXML.
Yeah, exactly. About proprietary things in the automotive world. I was just wanted to get some opinions and ideas.
So to your question, how do you know what is the padding, what is the freshness value? It's in the ARXML.
It's in the XML. Yeah.
So the autos are specifications already tell you where.
Yes.
You just need an ASML from either a template or one from
Yes.
the
So-
OEM.
So AXML
it's
would be
not
the
a question.
solution. Exactly.
You have the solution already.
Yes. All right. Yeah. And thank you. So then, my last question is, what issues do you face when you work or start with Scapy? Especially start with Scapy. I would like to understand a little bit the user problems and to see this as a user feedback. Like, for example, is performance an issue for you, or memory consumption? Is the how to getting started difficult? Would you prefer better documentation or more tutorials or anything else? Just give me feedback on this one, just to get some user feedback here. Okay, thank you. Yeah, memory is interesting. If you have a lot of packets, then it can quite explode. And yeah, you should really think about serializing packets or to byte streams or PCAP, and make things better. Maybe use pipes. Okay. Then, yeah, thank you very much. We are pretty much in time. Speed, okay, speed in terms of network speed, I guess. I mean, the global interpreter lock is always a pain. So, yeah. Any other comments on this talk? Any questions that you have? Otherwise, we have to close this talk. So thank you very much.